Hello everyone, welcome to my talk about what about architecture slice of domain-driven design. So I'll just go through the agenda for today. I just basically talk about domain-driven design concepts, then I walk through what drives choosing an architectural style. Then I go to the layered architecture, and after that I will talk about an improvement on the layers architecture, which is called dependency inversion principle. And finally, I talk about hexagonal or ports and adapters, and I list other architectural styles that could be useful in different scenarios. So let's get started. So domain-driven design is the concept that the structure and language of your code should match the business domain. And what it does mean is that usually when you try to write a software in an enterprise company, you usually have business experts and business analysts who come up with the actual use cases that will help business grow or be competitive. So, for us as developers, the idea is to be able to design the software in a way that reflects that business domain. And when you, as you can see here, it talks about the structure and language. And language here does not mean like programming languages. It's more like the naming and the terms that you use in your code should match with the language that, it's like a human sort of talkable language that you use when you talk to your business domain experts. So I'll just talk about some of the high level concepts with regards to domain driven design. By the way, this is a concept that is coined by someone called Eric Evans, and I strongly recommend to watch some of the videos or maybe the book that he has written about domain driven design. And it's all about the ubiquitous language. And this is the language that is kind of shared and sort of compiled between domain experts and the tech people, right? So you want to talk the same language. Now, three of the main concepts with regards to domain driven design. The first one is bounded context. A bounded context is a defined part of software where particular terms, definitions, and rules apply in a consistent way. So think of the bounded context as a logical boundary that everything within that boundary is very well defined and is very explicit, right? That's like a bounded context, and I will get to that in a little bit. Now we have the core domain of your project or software, and that's where you know that's the part of your software that is non-trivial to solve. It's hard to solve, and if you solve it, it gives your company a new competitive advantage over other competitors, right? So think about it as this example, like Amazon has like a shopping website, right? When you go online, it acts as a retailer website. But on the other hand, their framework supports like sort of cloud computing, like what they call AWS, right? And that's at some point that had been their core domain because it gave them this. It was non-trivial, of course, to solve, but also it gave them a competitive advantage over others. So a lot of people started using. So at that point in time, whatever effort they did was kind of their core domain. So it's a moving target. And then you have subdomains, and subdomains are any logical separation of services you might have within your business that are not really core, right? You still need them, they're essential, but they're not core. So let me give you an example of an e-commerce platform, right? The picture on the right, you can see that it has some solid lines, like we have e-commerce system, we have inventory system, and we have forecasting system. So these are our bounded context because logically in a retail service, we're talking about e-commerce. So e-commerce is that logical separation. Inventory system is another logical separation, right? So so basically in order to have to sell products online, the company needs to present a product catalog to the buyers, and that's like the catalogs that you see on the website, a way to place an order. Then it needs to be able to get the payment from the customer and then ship the products, right? So basically if you look at the e-commerce system bounded context, you have four subdomains here that you need to take care of. The issue though here is that having one bounded context for subdomains is a little bit not efficient, because imagine we have in this system we have a definition of a customer like me or you who goes and buys something. So for the product catalog subdomain, the customer means something else than the what customer means for the order subdomain. In a catalog subdomain, you usually think about, like, the history of the user in terms of like previous purchases and the discounts and all that. But when it comes to order subdomain, the only thing you care about the customer is their shipping address, their payment terms, and maybe if they have any credit on it. So you can see in this bounded context within the subdomains, there are terms that are not clear enough. So what we need to do is to define the bounded context to be explicit on the terms that either of these subdomains work. So basically, each of these subdomains will have a model that represents the customer in a different way, right? So for example, order subdomain has a customer sort of entity or object that has like shipping address or a credit, whereas the product catalog has different types of representation for that customer, even though uh, generally speaking they are the same thing. So going forward, this is more like a general domain. It might be a domain that you might has actually seen, or you've worked in a company, you probably have this kind of domain. If you look at this, you can see that there is no one bounded context with multiple subdomains in it, right? So previously you could see e-commerce bounded context had 4 subdomains in it, and this becomes really hard to maintain, because later on, if you want to add new concepts and all, you need to apply them in a very different fashion in different bounded contexts, in sorry, one bounded context. But here you have different bounded contexts for each of the subdomains. Though I should say that uh, you should notice that a bounded context could potentially slice over 2 or 3 subdomains of different types, as you can see in the center. So that's very important. There are 2 terms here that I want to talk about when I talked about subdomain. So as you can see, subdomain really means all those services that mean specific thing in your domain. But we have supporting subdomains and we have generic subdomains. Supporting subdomains are those sort of models or the things, the entities you define in your software that are essential and specialized, but they're not core, right? They are really essential, but they're not core. And also we have generic subdomains are the sort of domains or subdomains that they're not actually important, but they're not special, but they are required anyways for the overall success of the business. And those are the subdomains that you can pretty much change. So for example, let's say you have used a service from one company for a specific task to do for your generic subdomain. You can talk to another vendor and pretty much replace that vendor with another vendor, or you're using a company to get some service, you can use another company for the same service, maybe even better. But you can't do those for the core domain and supporting subdomains that you have that are tightly coupled to the services you have in your own company domain. So one important thing that I want to care about here and mention here is that you always need to talk about the experts. One of the mistakes that a lot of people do when they want to create a product, either it's a startup, it's a hobby project or whatever, that you want to productize, you always tend to like make decisions. Since we are technical people, we tend to make decisions that are technical. They are not reflecting what the domain experts or what the business really wants. So it's very important, because business software is the reflection of their mental map or the domain expert's mental mind map that you will implement in your code. And this software will become sustainable, understandable over the long period of its existence. So try to discuss some of your subdomains and context or whatever you come up with whoever it is, your friend who is a business person, your product owner. Just listening, sitting and talking to them will give you a lot and give you a lot of experience in that. And by the way, all the things that I talked about with regards to domain driven design so far is all about strategic design, right? You strategically try to design your language with the experts, the terms that you want to use, even the use cases you want to do. And then the next step is the tactical design when it comes to, well, choosing an architectural styles and actually start coding your software. So next thing is what drives choosing an architectural style. So the more important or the most important thing here is the real demand for a specific software quality. You want to use an architectural style that mitigates the risk of failure rather than adding failure to your software. It's all about functional requirements. And by the way, we have functional requirements to develop a software and we have non-functional. Functional requirements are all those use cases that you're trying to solve the customer problem, right? For example, create an order, right? Or create a customer or update a customer. These are functional requirements that, the business person or the product person asks you to do. And that's the most important thing to drive the architectural styles. And if you're working within a team, it's all about team decision. So following an architectural pattern is they're just patterns and you can tune them. You can use them however you want as long as you agree with your team how to basically organize your code based on those architectural styles and it actually reflects the business use case, it is good enough. Again, a lot of times you hear people saying that, oh, I want to use this architectural style or that architecture seems to be pretty cool. But I just want to mention it's not a coolness factor. You just want to make sure that you use an architectural styles and you're aware of the fact that it actually reduces the failures in your system rather than introducing unwanted new ones. So the next thing now, I dive into the tactical or the actual real architectures. So the first one is called layers architecture. It's the granddaddy of all the architectures. As you can see on the right side in the picture, it tries to tell you that you want to divide your software into a couple of layers. So obviously from top to bottom, you have like your user interface layer. That's where the customers talk to your software. Then you have an application layer, which basically is involved in sending the requests from the user interface into your core, your business logic of your software. And then there is an infrastructure layer. So let me just walk through some of the meanings of they are. So user interface layer addresses view and request concern, right? If you're writing a front-end application, that will become your view, right? But if you're doing a backend application that where you get like, let's say REST APIs or any kind of API, that's where you get your API. And you don't want to put any sort of logic in this layer. The only thing you can do is just validating that the inputs that you get or the query parameters or post parameters or however you call your API, you want to make sure that those inputs are validated. So if you're expecting a string, you want to make sure you get a string. And if the string needs to be 5 characters, you want to check if it's 5 characters and otherwise raise an exception or return an error message right away, even before going into your application. Application layer contains application services and it's very light. What it is really, it expresses the use cases that you come up. For example, if you want to add a customer, this is where you pass along the parameters to add a customer through the methods of the services within this layer. And it controls, persistence and security. A lot of time APIs work with an API key or there is an OAuth authorization going on. You want to put those authorizations right before entering your core logic in the application layer. And I'm going to show you an example of that. Then you have infrastructure layer. This is all about technical components and frameworks that provide low-level services. For example, you use a database or you use a messaging system or however you want to, let's say, save your data or send an event to another system. Then all the technical infrastructure lives here because, for example, for storing, you might use MySQL, SQL Server, MongoDB or whatever, or for sending messages, you might use Kafka or RabbitMQ, whatever. Those logics, those core frameworks and implementations all live here. So a sample application service is like that. So let's say from the business side or the product person, they want to add customer order, right? So here you get an access token and then you get a product ID that you want to add for that order. What you will do is you try to use it's a concept called repository. You have customer repository and product repository. These are basically high level abstractions over the communication with the database, right? Or it could be a REST service that you use to get a customer, right? So you pass the user ID of the access token to defined by ID method of this, and that kind of method will return a customer. And then you get a product from the product repository by the ID of the product ID. And obviously you call another service order service, which is the meat of this application service, to add order for this customer, right? So this is, by the way, a Java code. If you're not familiar, it uses a bunch of things with regards to Java, but it generally is the same concept in all the languages. Now, the layers architecture has some downsides. So let me tell you what the downside is. So domain layer is supposed to work with infrastructure layer, because in this scenario, in the layers architecture, the only way these layers can couple is to themselves and the layers underneath there. So application layer cannot reference anything in user interface layer, or the same goes for domain layer. The same way infrastructure layer cannot reference anything in domain layer, and that's unfortunate, because in order to develop something like a product repository, then you have to put the implementation of the infrastructure in the domain layer, and that's not what you want, because domain layer is not supposed to know anything about the implementations here. So unfortunately, for example, if you have like a, let's say, big table, you use Google's big table for your database communication, then you have to implement the big table product repository inside a product model in your domain in the implementation sort of namespace or package, which is not wanted. And that's why we come to a new improvement on this, which is called dependency inversion principle. So instead of having infrastructure on the very low bottom, you put it on top. Right now, the infrastructure can have references to all these three layers, and the same goes for the layers underneath them. So based on this, and this is a concept coined by somebody called Robert C. Martin, it says high-level modules. So these are high-level modules. We're talking about domain layer, application layer, and user interface. They should not depend on low-level modules. Both should depend on abstractions, right? And abstractions means that domain layer will define like an abstraction or the methods that are needed for its operation, and then let the infrastructure layer, which is the low level, to implement what the domain layer means. And I'm going to show you what it really means at the end. So look at this, for example. This is a code that is the business of it is all about user changes. So the changes that gets applied to a user, whether it's like a, I don't know, like they change their address, they change their email. So as you can see, I get the request through the API namespace, and then whatever I get, I do some validations on the input, and then I pass it to my domain layer. And in domain layer, the model that I have is called change, because change represents the model that I'm talking about in this context, which is user changes. And now with regards to the DIP or dependency inversion principle, you can see that the only thing I have defined, for you guys who know Java, by the way, I defined an interface just called change repository. And that's the only thing this domain needs to care. It has some methods in that interface, but they are not implemented. And then in the infrastructure layer, I basically, depending on what sort of technology I use to implement that change repository, I can have a MySQL, can have a big table. And then as you can see, in the change repository MySQL, I have actually overridden the find by user ID that this change repository has, right? So then this is the implementation that I need to pass it a user ID and then gets the change related to that. So next, I want to talk about hexagonal or ports and adapters. This is another architectural style. It talks about, most of the time we talk about backend systems, front-end systems, but in this case, we only have inside and outside, right? So the inside here is the application and the domain, and the outside is some things that are called ports and adapters. And I can just describe a little bit what they are. So ports are some of the things that we use in order to, for example, talk and get the request from the client. HTTP, gRPC, other. So for example, Apollo is like a framework in Java that is responsible for handling HTTP requests, right? There is another one called Drop Wizard that is very common in Java world, and you usually don't implement the ports or the gateways that you have. What you implement though are the adapters. And what adapter does is just a method that gets all the query parameters or all the inputs from the clients and then converts it to something that your inside or your application and domain understands, right? And then the same goes with if you want to save something to a database or send a message that's within the outside of the boundary of your application. So that's the concept of hexagonal, and I'm going to show you some things, some code that represents this. And finally, I want to talk about architectural styles that I haven't listed. One of them is called service-oriented architecture, and this heavily was used in Amazon back in the days. And one day, the owner of Amazon comes and says, I want all the services, all the things we have, all the sort of subdomains that we have in our system to be services, and each service needs to have an interface. So from now on, services need to talk to each other through those interfaces rather than, for example, some of the sort of subdomains share the same database, right? So no sharing at all whatsoever, but they should talk through the interface of their services. The other one is probably the more common known, architectural style is REST APIs. So I'm not going to dive into that at all. The other one is CQRS. This is recently becoming more and more popularity because it's about command query responsibility segregation. What it really means that instead of having an API that does have bunch of endpoints for sending like requests to update like a entity like a customer, and then you have another one that returns the customer to the client, you're going to have two different services handling each of those. So you're going to have a service that kind of the only thing it does is receiving commands from the clients to do something. So they usually update the state of whatever you have in your model, whereas query service just queries the objects out to the client and there is no change in the model. The other one is event-driven architecture, and this is all about, so web, as you know right now, when you go to google.com and you use some REST APIs, it's most likely it's synchronous. So you send a request and you get a response back. Event-driven architecture kind of tries to say, I want to do things asynchronously. I will send a request, I will send an event, but I don't care what happens to that, right? So for example, if I place an order, I can create an event called placed order. And then another system that needs this data can react and subscribe to this event and get that event and does what it does, right? Or proceeding with payments or, proceed with shipment or whatever. This makes the systems to be specifically if they're complex to be able to kind of become bigger and be faster in development and while being functional. So I hope you enjoyed this. Now I want to show you a little bit of a code here that I developed for another talk actually, but I created an order service in Java, and by the way, this is IntelliJ IDE. I have an API layer, and this is where I have my sort of in hexagonal, as I showed you, ports and adapters. I have one for HTTP, that's the REST, and I have one for AMQP, which is a protocol for say, receiving messages. So in HTTP, I have an order service, as you can see here. This sort of resource receives a request for, you know, uh, sort of creating an order and then getting an order for a specific customer or get orders in general, right? So this is what you have in terms of the API layer, and it doesn't do anything else. Then we have application layer, and in the application layer, I have like this customer event handler, which receives an event and then reacts on top of it. So for example, it has a handle method that receives the event that this system gets, and depending on what they are, it specifically does something with regards to an order. For example, this updates an order status, right? And then the order service is the application service that I use to create an order and to update an order, right? So in the API, as you can see in the HTTP order resource, when I ask to create an order, the only thing I do is to call the application service order service to create an order based on the request that I get, right? And then obviously in my model, which is the core of my application, what I do have here is that I have my model which an order is represented here. So this is a representation of an order object which has an ID, it has the items that an order have, it has a status, and also the customer that actually requested this order, and then bunch of events that I emit from my system. And then within my domain, I also have an order event publisher. What it does is actually publishes the events of my system to other systems to react to that. But if you notice here for domain event publisher, it's actually just an interface. An interface is just an sort of a uh, representation in Java and some of the other languages that you define the contract of the class that you want to use. So this interface needs to have a publish event, and this is the parameter it gets. That's the only thing that I have in domain sort of layer, and I only work with this. But then the implementation of it resides in infrastructure, right? The same way I have an order repository. What it does, it saves an order and it also lists all of my orders. I have the implementation sitting in infrastructure. So if I can show you, I have an in-memory order repository, which is actually basically a list of the orders that I can basically add or save or get it. So you can see that by doing this separation, now I can use in-memory order repository or MySQL order repository, because the only thing this class does is to implement this order repository that has the save and get all. And then I don't need to know the implementation of this within my domain layer, right? The only thing the domain layer knows is this domain event publisher or order repository, and that's how it uses it. And then you obviously have an app that you kind of inject all of these dependencies that you need to your application. So for example, for the event publisher here, I have used the Kafka domain publisher, and for the order repository, I use an in-memory order repository, which is just a list in the memory. So yeah, I hope you enjoyed this talk. I think I condensed it a lot, but I hope it gave you a lot of clues about how, technically speaking, you go about making an application that is resilient. You can distribute it, and it's very well qualified for the qualities that you expect and the business expects for your software to have. So I hope you enjoyed this talk, and I'll see you next time. Goodbye.